Welcome everybody. We are expected to find the side of the equilateral triangle. Now let me draw the figure. Now this is the figure that's being given. Okay. Now we have got a structure that is oriented in this fashion. So let me draw that. Now there is a connection this is given as P, this is given as Q. We expected to find the length of this side, right? Okay, so this is an equilateral triangle. Now what I wish to do is I would like to take the sides to be as A units, and A units. Then I will drop the bisector to, let me just take this as A, B and C. So I'm dropping the bisector such that there is a 90-degree made here. Now this is a structure. Now your visualization should be in this fashion. This is a equilateral triangle which initially adds some structure to support it, and then there is a shift. So that is the visualization you need to have, right? So this shift is given to us and we are expected to find the value of A, right? This A is required. Now there are a few things which we can decide from the figure. Now imagine that the angle of shift from the bisector, right? So this is the height of the equilateral triangle. From the height there is a shift of alpha. So this is alpha, then this is taken, okay, this is assumed. This degree is assumed. Now we are actually going to be looking at this particular triangle. Now I know this is 90 degree. I am taking this part to be as 30 degree positive alpha. Now you might be wondering, why am I taking it like that? Now my intention is to get the value of A, right? Now you will know why I'm taking this as 30 degrees plus alpha. Of course you can take it as some quantity of a degree plus alpha, and over here this is going to be 30 degree negative alpha. Now whatever angle that you're placing here, this angle has to be placed here. So that is the shift that you are perceiving. Now the most important part of this particular solution is taking this as 90 degrees and this as 90. Now there might be people who would say, wow, I wish I had known this as 90 degree. Now if you are not going to be taking this as 90 degree, how are you going to solve this question? That is the important aspect. Now there is another important feature that you'll have to know. Just by the concept of right triangle or right angle, you can name it as right angle or right triangle, whatever you want. Using this concept that is present in a triangle, the right angled triangle or the right angle present in a triangle, buildings were constructed. So have that in mind. In most of the questions that you will face, or even a challenge you will face, all the information will not be given to you. So it is your responsibility to perceive the unseen. That is what is called as the art of problem solving. So having mentioned this, let me move up. Now, there are also situations and cases where you will have to guess and check, right? And that is how things work in certain problems. Outrightly, you may not be in a position to obtain the solution, but you will have to guess and check and zero in the required solution. Okay, having mentioned this, what I'm taking here is, I'm taking this shift to be as alpha. Subsequently, this shift is going to be 30 positive alpha, and this is 30 minus alpha. And I've given you an explanation why am I doing it like this. Now, what I would do is, I would be considering this to be the first triangle. So I've taken ABC, I'm going to take this as D, I'm going to take this as E. So what we will do is, we will consider triangle D, C, and A, right? So this is what we are considering. So this angle is going to be 30 positive alpha. So this is going to be 30 positive alpha, and this distance between D and C is going to be P. We know it is P, right? And this hypotenuse is A units. Let me write that. That is going to be A units. So what I'm going to do, I'm going to use sine of 30 positive alpha. Why am I using this, or how am I able to use this? We are able to use it for the very fact because it is a 90-degree angle. There is a 90-degree present here by the rule of right triangles, and sine is a trigonometric ratio. So using that, what I'm going to do, I'm going to take sine of 30 positive alpha is equal to opposite side divided by the hypotenuse A. So from here, I can rewrite P to be as A times sine of 30 positive alpha. This is always possible, right? So I've got equivalent or one representation for P. Now let me consider this angle. So I'm going to write it down here. Consider, let me draw that. So this is going to be EC. I stretch this and I draw the hypotenuse. So hypotenuse is BC and BC is A unit. So this is what I'm considering, right? This part, and this part is 90, and this angle is 30 negative alpha. This side is Q. So let me take sine. So sine of 30 negative alpha is equal to opposite side Q divided by hypotenuse. So therefore Q is equal to A times sine of 30 negative alpha. So I've got two systems. I've got a system here and I've got a system here. So what I wish to do is, I would like to add 1 and 2. So let me write it down here. Adding 1 and 2 we get. So what do we get when you add 1 and 2? This is P positive Q is equal to A times sine of 30 positive alpha positive A times sine of 30 negative alpha. So I can take A out, and that would give me sine of 30 positive alpha and the positive sine of 30 negative alpha. I'm going to use sine of A plus B formula and sine of A minus B formula. If I were to do that, I would get the value as sine 30 divided by cos alpha positive cos 30 times sine alpha positive sine 30 cos alpha negative sine alpha cos 30, right? Cos 30 sine alpha, cos 30 sine alpha, they can be cancelled. Now you got sine 30 cos alpha, sine 30 cos alpha. So that's going to be 2 times A cos alpha times sine 30. Sine 30 is 1 over 2. So 2 and 2 can be cancelled, giving me A times cos alpha. So what is this? This is nothing but P positive Q. So having got that value for p positive q, let me now consider p minus q. Consider p minus q. So what is p minus q? P minus q is equal to a times sine of 30 positive alpha negative a times sine of 30 negative alpha. So this is going to be a times, if I were to write the formula, there is going to be a negative sign here, right? So sine 30 cos alpha positive cos 30 sine alpha negative a times sine 30 cos alpha positive, I don't need to have a there, positive sine alpha times cos 30. So this and this will be cancelled. So I would get a times, now cos 30 is what? Root 3 over 2, right? But there are two components as there. So this is going to be 2 times root of 3 over 2 times sine alpha. 2 gets cancelled, giving me a times root of 3 times sine alpha. So I've got two components here. I've got this and I've got this. So now what I wish to do, I'm going to take this as 3, I'm going to take this as 4. Now I'm going to use this part of the page, right? I'm going to take 3 squared plus 4 squared. So what is 3 squared plus 4 squared? This is going to be a squared cos squared alpha is equal to p positive q raised to the power of 2. And this is going to be a squared root of 3. Root of 3 squared is going to be 3 there times sine squared alpha, because when you square the square root it becomes 3 and sine squared alpha is there. And this is going to be p negative q raised to the power of 2. Now what I wish to do is I would like to move this down there. So this is going to be by 3 here. So you don't have to use this over here. Because of the lack of space, I don't want to have one more step. I'm just trying to minimize the number of steps. I hope you understood this. So I'm just pushing this 3 down. So you got two components here. So I add these two things. You want to add it. When you add it, you get a squared of, what do you get? Cos squared alpha plus sine squared alpha is equal to p positive q raised to the power of 2 positive p negative q raised to the power of 2 divided by 3. Now this is 1, right? This is 1. So what have you got? Now let me use probably I think this is the best part to use. Okay, so I'm using this part. So what I've got, cos squared plus sine squared is 1. So I've got a squared here. So a squared is equal to p positive q raised to the power of 2 divided by p negative q raised to the power of 2. Now if you want, you can expand this. So this is going to be p squared positive 2 times pq positive q squared, and this is going to be multiplied with 3 positive p minus q whole squared. So p squared positive q squared, and then negative 2 times pq divided by 3. So this can be rewritten as, now 3p squared plus p squared, that's going to be 4p squared, and 3p squared, 3q squared plus q squared, that's going to be 4q squared. You got 6pq and minus, that's going to be 4pq divided by 3. So this is equal to, take 4 out, I take 4 out, I get p squared, I'm going to write it as pq plus q squared divided by 3 is equal to a squared. So this is the value we got for the side. So a squared is this, and clearly you can find out the value of a. So you have whatever value that you get here, you take the square, and then subsequently a will be 2 over root of 3, and you take the square root of the entire quantity, p squared plus pq plus q squared. So this is in units. This is the solution. This is the final solution that we have got. Now from this figure, p is given, q is given, so a can easily be found. So that is the end of this particular problem. Thank you. Enjoy your night.